Hello, and this week's video is going to be about the second derivative test, which is used for finding a local minimum or maximum. So if you've seen my video previously about critical points and finding the maximum or minimum point, you might be familiar with this process already, but this just goes into the second derivative test a bit more deeper. So what are your steps? First, before you apply the second derivative test, you have already found your critical points. And then you use the second derivative test to test these points. So if you remember, the critical points are when f prime of x is equal to 0. And what the second derivative test tells you is that if the second derivative of the critical point is positive, then there's a local minimum at that point. However, if it's negative, there's a local maximum at that point. And let's see why this makes sense. So say you have a function, something like this. We can see that there is a maximum point right here, and another one right there, and there is a minimum point right over there. Now, if we think about what the derivative of this function does, it basically goes like this, the slope, and then over here it has a critical point where f prime of x is equal to 0. Then over here at the minimum, it also has f prime of x equals 0, and over there f prime of x also equals to 0. Now if we think about the second derivative, and let me quickly draw these little lines in order for you to be able to see exactly what I mean. So let's say that these lines are the tangents or the slopes. Obviously this is very broad, but you can see that here the slopes are decreasing. That is why your f prime prime of x is going to be less than 0. Now if you look at the minimum point, your slope starts to increase. Look, it goes from negative to positive. So your second derivative, f prime prime of x, is going to be greater than 0. And then would you look at this? When we come back to a maximum point, once again, our second derivative is going to be less than 0 because the slope is decreasing. It starts off quite steeply and then it decreases by the time it reaches the critical point when the slope is 0. So let's look at an example. Here you have a function, and this is really random, and it graphs like this. Now, if you take the derivative of this function, you get this graph. And would you look at that? These are the critical points, exactly over here. Now, this one at x is equal to -1, and this one at x is equal to 0, when you look at the second derivative, x is equal to -1 is a negative value, which is exactly showing that this is a local maximum. Now x is equal to 0 is a positive value, which is showing that it's going to be a local minimum, which is exactly what we can see right here. So I hope this gave you intuition, and I hope you now know how to use the second derivative test. It's very simple. All you have to know is the logic behind it and why it makes sense. And that is really the key to it all in math, because it's actually very quite simple and beautiful once you understand and really get into the process of thinking in a mathematical way. So I hope you enjoyed, and keep the second derivative test in mind. As you can see, it's very time efficient and it's a great quick way to check whether you have a local maximum or a local minimum. What is to be said is if your f prime prime of your critical point is 0, this is inconclusive. It could be an inflection point. It's not a local max and it's not a local minimum, but this is a video for another time. So hope you enjoyed. See you next time.